Hello, Mr. Mr. Ryan, right?
Mm.
Okay, so remember a few days ago we talked about counting the number of houses, a shape of a circle. We have three more methods, which is door close. Actually, these two are, basically the same, right? It's door open, it's door close. You just put a knot. Close door, open door, and move right, move left. So previously, we are allowed to use these 6 methods, and we want to count the number of houses, right? So we are standing in front of any house. Initially, the door could be open or closed, and there is no difference between any two doors. So in other words, you do not remember which door you are open or closed. Okay, so you cannot use any headset or make a label on the door. You cannot do that. So at that point, how do we count the number of doors? Number of houses? Do you still remember?
Leave one open.
Yeah, leave one open. Yeah, but how do we leave one open? We need to
open one.
open one. We close all the doors,
Yeah,
right? And then open one. Okay, so there's an upper bound. The number of doors are no more, bless you, no more than K. Okay, the number of doors no more than K. Basically, we use the status of door, open or close, as a marker. So we close all the doors and then we open the door until we cannot do so. It takes up to K iterations. So in this case, we can count the number of houses on this circular street. We need to use the closed doors and we need to use the open doors, right? So once all the doors are closed, we open it. So look, it's all closed, then we open it. +1, open it, +1, open it. And then we come back to the first door. So we need to use the closed door and open door. Okay, so today, similar question, but you are not allowed to use this method, and this method anymore. Okay, so you're only allowed to use these 3 methods. Checking the door to see if it's open. Close the door. Okay, close the door if it's open. You can close the door which is already closed. Okay, and move right. Actually, the move left, move right doesn't matter, right? In a circular, you can just use one direction. You can move left or move left.
What if you accidentally move right?
What do you mean accidentally move right?
For example, you have the one you want, and then you accidentally move. Definitely could happen. Oh, never mind.
So another criteria, at least one door open, okay? Initially, you are standing in front of any door, which could be open or closed. Okay, so any idea how do we do this in this
So
in this new
leave one open. You check if one is open. Since you checked, at least one is open. You find the one which is open.
Yeah.
And
Okay.
then,
Very good.
And then just close all the other doors and count the closed doors.
Close all other doors and
Count them and +1.
close all other doors.
Yeah.
Okay, so at least one door open. So we first of all we find out which door is open, right? We can easily do that, right?
Yeah.
So we can say white door is not open, white door is closed. Then we keep moving right until we are at this point. Okay, so suppose we are here, and then the door is open. Here is open. So now what should we do?
And then move to the next one and then close all the other doors.
Yeah, I close it and then I move right, close it. But when do we stop? The thing is, when do we stop?
When you go back to the door that's opened.
Yeah.
Yes, we're done. Yes, when we go back to here, right?
Yeah.
Yeah, when we go back to here.
No,
But it's slow.
yeah, but
But
I
very
just
slow.
realised that
Yeah.
if there's another open one here, we just stop here.
That's right. Yes, I was going to say that. How do you know this is not the case? So when do we stop? Does it matter?
You just
How about we count? How about we don't close any? But how about we go through all of the houses and check if how many
count how much are open, count how much doors are closed,
Yeah,
and then add them.
You count how much doors are closed.
When do we stop?
X marks the spot.
We don't know, when we reach back, right? So that's the thing. Because if you're saying that, okay, we count all others, what are others? When are we stopping counting?
How about we open them instead of close them?
We can't. We only can use the close.
How about
Remember, we can't use these three methods. We can only use these three methods. Check the door open or equally check the door
you
closed.
check
If you know the door is open, you also know if the door is closed, right? This is basically the same thing. Close the door, but not the opposite. You can close the door, you cannot open the door.
you use K and then you move K. Wait, you have to leave one open, which is open.
Yeah, here now I'm already open here.
Yeah,
One
you
here.
use K. You use it by going K times. If it
Yes, yes,
if it's a closed door.
yes. If it's open door, right?
Yeah, if it's an open door.
Then we close it. Yeah?
Yeah.
We close it. We close it and we update the distance, which is we know the distance, right? So this K means that we can try at most K times, right? If we work K times, we certainly come back to the origin, right? Alright?
Yeah.
Okay, so now you're right. Okay, so let me get this. We open this. We can move to a door, to the first door, which is open. Okay, but we're not closing this for the moment because we can come back to this. Now we move right here. We start from this, right? And if this door is open, we close it. We update the distance. Now distance is 1, right? Now distance 2. If it's open, we close it and update the distance 2. Okay, if it's closed, then bless you. If it's closed, then we skip. Okay, this door is open, right? I close it. Okay, but I need to move K times. I need to go here, until we go here, right? Yeah. And then this door is open for sure. Then we update the distance, and that's it. Make sense?
Yeah.
Yeah.
Yeah. Yeah.
Bless you, mommy.
Yeah.
Okay, so do you see how we solving this problem?
Yeah, but
Yeah.
So can you explain to me?
So.
Yeah.
So you find a open door.
Yeah.
You leave it open.
Yeah.
For the moment, and
Yeah.
then you move on to the next one by going
Yeah.
right. If it's open, you close it. If
Yeah.
it's closed,
This-
you still are like update like the distance.
If it's closed, then we don't update distance. If it's open, we update the distance.
Oh yeah.
If it's open, we update the distance.
Yeah.
And the number of houses equals the distance plus 1, right?
Yeah.
Okay. While, okay, define, count, and we have this street object. Why s dot is door open? Is door open equals false? Why not? Right? Why the door is closed? Then s dot move right. Okay, here there is a slight problem, right? If all the doors are closed, then this will go into infinite loop. Am I right? If all the doors are closed, then this will not work. But we are given that at least one door is open, so this is okay. Otherwise, we can do this. We can do the for loop for underscore in range k at most k times. And if s dot is door open, right? If the door is open, then we break. Otherwise, s dot move right? Okay. If all the doors are closed, this still works, right? Because it terminates after k iterations. Okay, so these two are the same thing, okay? These two are the same thing. So these two are the same thing. Let me just erase this, okay? Now we are here, right? Now answer equals 0.
can you half close and half open the door?
No. Okay, that's very good. No. Okay. Answer, let's say distance, okay? Distance equals 0. Now we need to move right at the beginning, okay? Move right. Okay, I use this arrow, okay? S move right. Yeah. Okay. At most k times, right? For I in range k. Because at most k times we come back to the origin, right? Then if S dot is door open, if it's open, right? If the door is open, then the distance equals I. the distance equals I plus 1, right? Okay, start from 0. And we need to close it, right? S dot close the door. And then at the end we return distance.
Yeah.
Yeah.
Why this works? Because at most k times we're coming back to the first one, which is open. If it's open, then we close it. When we close it, we update the distance. If we get the distance, we know the number of doors, right?
Yeah.
Awkward silence.
If this k is bigger, right? So if we bypass the first one, and then we are here, the doors will not be open anymore because at the first round, okay, at the first round these doors are already closed. Am I right? So the maximum distance is the number of houses.
Yeah.
Okay, so this is one approach. The other approach is quite similar to calculate the first open door, right? The first open door, which is the distance, and the last open door. Okay, it's quite similar. And the distance, the number of houses is last open door minus the first open door. Okay, this is open. This is the last open. Last open minus first open equals the number of houses. Okay, look, this is 0. 1, 2, 3, 4, 5, 6. So the last open is 6. Okay, so 6 minus 0, 2, 4, 6. Okay, yeah, and we use the distance to mark the position where the door is open. Okay, so it's a bit tricky for this one. So I'm not going to talk about this, but I'm going to post it in the blog. Okay, but the idea is similar. Okay, so what have you learned today?
About mostly the same thing as a few days ago.
Yeah. So what's different today?
We don't open doors.
Yeah, and if we can't open the doors, how do we count?
We keep the door open, count.
So we learned about a problem which is similar to a few days ago, except from we can't open a door. So the solution is that we find an open door because it says that there's at least one door open. So we find a door which is open, and then you carry on from that. And if it's closed, we do nothing and just
Move to right. Yes.
Yeah, and if it's open, we increase the
And then we need to close it.
Yeah.
Yeah.
And then if we go around k times, there's a door open, then it must be k. No, wait.
The k times, just make sure you travel at least one circle, right?
Yeah.
But we're going to meet this first door anyway.
Yeah.
When we meet it, we update the d, which is the
Yeah.
Okay.
I'm saying that if you go around k times, and then on the k whatever time,
Yeah.
you find an open door. Yeah.
Yeah, basically same thing.
That's
Yeah.
what I'm saying.
Good. Okay. So it's okay. We go bypass the first door. K is bigger, like a million, right? And we're going to travel this around and around. It doesn't matter because each door, if it's open, we close it immediately. We are not closing it the second time. If we're not closing it the second time, we are not updating the distance the second time. The last distance we're updating is this one, the first one, right? Does it make sense? The second method, second method is that we track the first open door and the last open door, right? And then if the first open door not equal the last open door, we close it, and then we can use these two variables to do this. It's quite similar to this, just slightly different implementation. Okay, that's it for today. By the way, the time complexity, okay, because we're traveling k time. The space complexity, 1, considering opening door is very trivial. Okay, opening the door, closing the door is trivial. 1. That's it for today. Bye.
Bye.
Bye.